Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 13, analytic proofs of theorems previously proved by synthetic means. Okay, so here we go. Classwork opening exercise, let A 3040, B is the point 6050, and C 75 120 are vertices of a triangle. Find the coordinates of the midpoint M of AB. So let me highlight that. Find the coordinates of midpoint M of AB and the point G1. The point G1, that is the point 1/3 the way along MC, closer to M than to C. All right, so those are the two things we want to do. Let me switch back to my pen now. And so let's review a little bit here. Let me draw a diagram up above. So if I have A right here, and that is the point 3040, and I have a segment going over like this, and this is B at 60, 50, we want to find the midpoint using synthetic means. So we're not going to draw diagrams and graph this. What we're going to do is take the midpoint formula, which equals x sub 1 plus some ratio, I'll put AB here for now, x sub 2 minus x sub 1, comma, y sub 1 plus the same ratio, AB, x sub 2, I'm sorry, that's y sub 2, y sub 2 minus y sub 1. So this is the midpoint formula in general if AB were a half. So now I'm going to change that. If we're doing midpoint, this is going to be a half. If we're doing a percentage or a ratio, then that will be different with respect to each ratio we're trying to find. But for midpoint, this is always 1/2. So let's substitute in our values and find the midpoint of this segment. So we're going to call this x1, y1, and this is x2, y2. So then we just simply substitute. It's very simple. So x sub 1 is 30 plus 1/2 x sub 2, which is 60, minus x sub 1, which is 30, comma, y sub 1, which is 40, plus 1/2 y sub 2, which is 50, minus y sub 1, which is 40. And then substituting in, I will get M equals, well, let's just do this all in one step. 60 minus 30 is 30. Half of 30 is 15. 30 plus 15 is 45. 50 minus 40 is 10. Half of 10 is 5. 40 plus 5 is 45. So that puts M right here. And it is the point 45, comma 45. All right, so that was this yellow highlight. So the midpoint of AB, and I should have this down here, by the way, the midpoint of AB is 45, comma 45. Okay, so if you didn't write this down yet, pause it because I'm going to erase this. So now we are going to do it again, but we aren't finding the midpoint this time. The purple highlight says to find, oh, what did some of the highlight erase? It did. It says the point G, that is the point 1/3 of the way along MC, closer to M than it is to C. All right. So let me just draw this on this diagram here. So one point, midpoint of AB, and the point G1, that is the point 1/3 of the way along MC. So here's the midpoint M. So if I drew a line up, say this direction, we don't know which way it's going. I didn't even look at the coordinates yet, but this is just in general, just to get a picture. So here is C, and we'll call that 75, 120. So we have the midpoint, we have C, that's the segment MC, and we want to find it 1/3 of the way along. So our formula that we had here is now going to be, now I want to find G sub 1. G sub 1 will be X sub 1 plus, and the formula is the same, X sub 2 minus X sub 1, comma, Y sub 1, I'm leaving a space, Y sub 2 minus Y sub 1, but the formula has a fraction in it. There's a plus here. And the fraction is this value. We want a point here where this is a distance of 1 and this is a distance of 2. So the total's 3. So 1/3 of the way is a ratio of 1 to the whole thing, 3. So that is my fraction when I'm finding a distance along a segment. Now I substitute in my X sub 1 and my Y sub 1s. And so now I'm just going to move these down here. Now my X sub 1, Y sub 1 is 45, 45. And my X sub 2, Y sub 2 is 75, 120. And then we just simply use this formula and substitute in. So G sub 1 is going to be X sub 1, 45, plus 1/3 X sub 2, 75, minus X sub 1, which is 45, comma, Y sub 1, which is also 45, plus 1/3 Y sub 2, 120, minus Y sub 1, 45. Okay, and then we're going to simplify this. And that is going to give us 45 plus, well, 75 minus 45 is 30. 1/3 of 30 is 10, comma, 45 again, plus 120 minus 45 is 85. Okay. And 1/3 of 85. Well, this one's not going to be as easy. So 120 minus 45 is 75. I'm sorry about that. 75. Now that'll work. 1/3 of 75. So 3 goes into 7 2 times. Bringing down 15, that's 5, 25. So 25. So I just showed all my work there. Did it in my head incorrectly at first. So there we go. And that is going to yield the point 45 plus 10 is 55, comma, 45 plus 25, which is 70. So this point right here is going to be G1, which is 55, comma, 70. Okay. And there's A. Okay. Part B says, find the coordinates of the midpoint N of BC. So let's highlight that. And the point G2, 1/3 along NA, closer to N than it is to A. Okay. So here's BC right here. So obviously this C is going to be over here further because this X is 60 and this is 75. So I should have gone over another 15 approximately over here. But again, like I said, this is just a guide, a diagram that's not to scale, just to help. So the coordinates of the midpoint N of BC and the point G. So let's just focus on this right now, midpoint N of BC. So now I'm just going to move my X1, Y1 over to B. One end is X1, Y1, and C is X2, Y2, and I want the midpoint N. So the midpoint N, so N is going to equal X sub 1, 60, plus 1/2, remember it's midpoint, so it's half, X sub 2, 75 minus 60, comma, Y sub 1, which is 50, plus 1/2 Y sub 2, which is 120, minus that 50. So N is going to equal 60 plus, well, 75 minus 60 is 15. Half of 15 is 7.5. And then 50 plus 120 minus 50 is 70. And half of 70 is 35. So that is going to give us the point 67.5, comma, 85. So that would be a point somewhere around here, 67.5. So it'd be over here if this were longer, comma, 85. All right, now let's focus on G2. So G2 is going to equal, and it's 1/3 along the way, NA. So BC is here. So let me just fix this a little bit. Let me drag that out. So let me just move this over here and make this longer, like so. So this is 75, 120. And what we just drew, I'll do it in purple. We did BC, okay, BC, and then we found the point 67.5, 85, which is right here, 67.5, comma, 85, which is the midpoint N of BC. Okay, and so now we're going to find G2. 1/3 away along the way NA. So now we're going to have this segment from A going to N, and we want to find a point on that that is 1/3 of the way along NA closer to N. So if it was, say, here, that's 1 and this is 2, we're looking for this point here. Okay, I know this diagram's not to scale and it's messy, but just gives you an idea of what we're looking for. And so now we do G2. And the formula is, so what are our endpoints? N and A. So N is now going to be X sub 1, Y sub 1. So I'll move these up here. And A is 30, 40. So those are X sub 2, Y sub 2. NA. Endpoints, X sub 1, X sub 2, Y sub 1, Y sub 2, NA. All right, so X sub 1 now is 67.5 plus, and we are going 1/3 closer to N. That's why N is X sub 1. So now we're going to do 1/3 X sub 2, 30 minus X sub 1, 67.5. Comma, Y sub 1, 85, plus Y sub 2, 40, minus Y sub 1, 85. And it's 1/3. Almost forgot that. So now G sub 2 is going to equal 67.5 plus, now let's just start using the calculator because of the decimal. Clear on, you there? Okay. 30 minus 67.5. And then 1/3 of that would be divided by 3, and that's 12.5. So it's going to be minus 12.5 because of the direction we're going. So 67.5 minus 12.5, comma, and then we're taking 40 minus 85. And that's negative 45. And we're dividing it by 3 because of the 1/3. And we're going to be minus 15. So that's going to be 85 minus 15. That is going to give us the point 67.5 minus 12.5. The 0.5's cancel. 7 minus 2 is 5, and 6 minus 1 is 5. So we get 55, comma, and 85 minus 15 is 70. So G sub 2 is the point 5570. And notice what just happened. It is actually going to be this point right here that we found to be the 1/3 of the way up MC. Okay, part C. Let me get back to my highlighter. Choose green this time. Find the coordinates of the midpoint R of CA and the point G, that is the point 1/3 of the way along RB, closer to R. Okay, so switch back to my pen. Let's use blue this time. So the first thing I want to do is find the midpoint R. Is that an R, by the way? The comma's in the way. Yes, R. So we want to find R. R is the midpoint of CA. So where is C? C is right here. So the first letter is my X sub 1, Y sub 1. So I'm going to move these X sub 1, Y sub 1s up to here. C is 75, 120. A is 30, 40. X sub 2, Y sub 2 is already marking those. And here we go. So it's X sub 1, 75, plus, and it's midpoint, so it's 1/2 X sub 2, which is 30, minus X sub 1, comma, Y sub 1, which is 120, plus 1/2 Y sub 2, which is 40, minus Y sub 1, which is 120. So when I do that, I get R to be 75 plus, well, 30 minus 75, and I'll use the calculator just in case. 30 minus 75 is negative 45, divided by 2 is negative 22.5, plus 75 is going to be 52.5. So I'll put a minus 22.5 here for starters, comma, 120 plus, actually it's going to become minus again, this is going to be negative. 40 minus 120 is negative 80. Half of negative 80 is negative 40. So it's 120 plus a negative 40 or minus 40. And that is going to give us the points. And I already did this one in the calculator, and it was 52.5, comma, 120 minus 40, which is 80. All right, now when I do the one closer to R than B, G3, 1/3 of the way along RB, well, what did we just find? We just found the midpoint of CA. So where is C in our diagram? It's right here, so let's draw that. I'll use, what haven't I used yet? Green in my diagram. So if this is CA, we just found the midpoint R, which is the point 52.580. Okay, so that's this point on this green line, halfway between A and C. Now we want to find the point G3 that goes from R to B. So now I'm going to cut through here, and we want to find the point 1/3 of the way, and I have a feeling it's going to be this G. Since I'm not to scale, it's off a little bit, but I'm thinking this is going to be a point in this center. Okay, it's going to be centroid. All right, all those points are going to end up right there. So there's what we're looking for, G3. So my R, and the segment's called RB. So R is going to be my X1, Y1, which I'll move over here. So 52.5 is X1, Y1 is 80. Okay, and then, here I don't have a close parentheses on that. And then X sub 2, Y sub 2 is going to be B. So I'll move this now down to B. So those are the values we're going to use to answer this question. All right, so I'm kind of running out of room here. So let's move these. I exploded them. Okay, I don't know why it does that. Oops. All right, I'm just gonna scroll up and down here. So we're looking for G3. We found G1, we found G2, now we're looking for G3. G3 is going to be x sub 1, which is 52.5, plus, now we're looking for something that's 1/3 of the way. So I'm gonna put 1/3 there along RB closer to R. That's why our R is our X1, Y1. So it's 1/3 X2, 60, minus 52.5, comma, Y sub 1, which is 80, plus 1/3 Y sub 2, which is 50, minus 80. So G3 is going to become, and I'll just do it all in one step here in my calculator. So the first thing we do is parentheses, 60 minus 52.5 equals 7.5. Divide that by this 3, and that will give me 2.5, and add that to 52.5, and that will give me 55. So this is the point 55, comma, and then I'll do the same over here. 50 minus 80 is negative 30, divided by 3 is negative 10, 80 plus a negative 10, or 80 minus 10 is 70. So G sub 3 is 5570, and if we go up, there is the point G1, 5570, G2, 5570, and G3, 5570. Okay, page 2 brings us to exercise 1, and it says, given triangle ABC with the vertices A, B, and C being the A sub 1, 2, B sub 1 and 2, C sub 1 and 2, find the coordinates of the point of concurrency of the median. So we're looking for the coordinates of the point of concurrency of the medians. Now let's go back a page. This is a messy triangle, but this black line, this is 1/3, this is 2/3. The blue line, this is 1/3, this is 2/3. The green line, this is 1/3, this is 2/3. The point 55, comma 70 was the point of concurrency of those midpoints. This is a midpoint, this is a midpoint, this is a midpoint. So we just did it, and that was our G1, our G2, and our G3, and they all came out to be, let me put boxes around them. 5570 is G1, 5570 was G2, and 5570 was G3. So the point of concurrency of the medians, since it is a point of concurrency, it's the same point. So if we find the median of one side and then do the point of concurrency, the 1/3, the distance to the other vertex. So let me explain. So if we had the point AB, or the segment AB, we found the midpoint of AB, and then we went 1/3 of the way along that midpoint. So midpoint was one end, and the other vertex C was the other end, and we went 1/3 the distance from the midpoint to the third vertex. That finds the point of concurrency. So I'm only going to do this one time, whereas the book shows 3 times, but that's not necessary. So let's just keep it simple. So first we need to find the midpoint. With respect to these points here, the midpoint of AB is going to be x sub 1, which is A sub 1, plus 1/2 x sub 2, which is B sub 1, minus x sub 1, comma, y sub 1, which is A sub 2, plus 1/2 y sub 2, which is B sub 2, minus y sub 1, which is A sub 2. And there is the formula for the midpoint of AB. Okay. Okay, so let me get a triangle here to explain this. Let's just say we have this triangle here, and I'm not necessarily saying it's isosceles or equilateral, so let's change it, and let's just rearrange its size somehow. I don't know if I can get it to, anyway. Let me just label this up so we just have an example. So if this is A and this is B, we find the midpoint by doing this. This is C. So then we have a segment going up from the midpoint to C. And if I go 1/3 the distance, say right here, where this is 1 and this is 2, 1 out of the total 3 would be here. That would be our point of concurrency. So that would be the point, whatever we want to call it, on MC. So we could call it anything, I guess. We'll call it N, as in Nancy, going with M, N, O in that order. The other way we can find this is a really confusing formula if we're going to substitute it into the other. So keep in mind that there's also this midpoint formula. The midpoint of AB equals the two endpoints. So it's x sub 1 plus x sub 2. And I didn't label these. This is x sub 1, this is y sub 1, and this is x sub 2, and this is y sub 2. So x sub 1 plus x sub 2 divided by 2. I could write it like that, or I could just say half. Let's just do that. So there's many ways to do this. So that's going to equal 1/2 a sub 1. I don't even need the parentheses. Or do I? Yes. A sub 1 plus b sub 1, comma, 1/2 the y's, a sub 2 plus b sub 2. Okay, these two are the same, but this one is much less complicated than this one. So we're not going to use this one, but it's still okay to write it out. We're going to use this one. So now that's how I find M. The midpoint of AB is this. And then I'm going to take that end and take 1/3 of it to find N. So N is going to be the point. So now keep in mind that this is now my x sub 1, and this is my y sub 1, and this is my x sub 2, y sub 2, the C. So we're going from M to C. We're finding a point 1/3 of the way along MC, but closer to M. So M is right here, the midpoint of AB, and that's this. So there's our x sub 1, there's our y sub 1, x sub 2, y sub 2. Okay, so here we go. X sub 1 okay, x sub 1 plus 1/3 x sub 2 C1. That's not a G, it's a C. C sub 1, right? X sub 2 minus x sub 1. Comma, y sub 1, which is 1/2 a sub 2 plus b sub 2, plus 1/3 y sub 2 minus x, or y sub 1, 1/2 a sub 2. I don't need a fraction here, or do I? Yeah, I do. Minus, so let me just check this. 1/2, this is my y sub 1 plus 1/3 y sub 2, which is C2 minus y sub 1, which is 1/2. I don't need a parenthesis there. A sub 2 plus B sub 2. Whew. Okay, so now we're going to simplify this further, and we're going to distribute these halves. So it is going to be 1/2 times A sub 1, which is 1/2 A sub 1, plus, distributing here, right? 1/2 B sub 1, plus, okay, so how am I going to do this? Okay, so I'm going to do this in 2 steps, just so we don't confuse. Leave the 1/3 there, parentheses, C sub 1, whoops, minus 1/2 A sub 1. Now again, I'm distributing this, plus 1/2 B sub 1. So this 1/3 will then have to be distributed. So we're going to do that in 2 steps just to avoid confusion. Distribute, and I get 1/2 A sub 2 plus 1/2 B sub 2 plus, leave that 1/3 there for now, C sub 2, distribute, minus 1/2 A sub 2 minus 1/2 B sub 2. So that's a -1/2 times a plus. So if I come back here, I made a mistake right here. This is not plus, it is minus. Minus 1/2 times A sub 1 is minus 1/2 A sub 1. A negative times a positive is negative 1/2 times B sub 1 right there. Okay. All right. So now that we've done that, we now have to just do one more thing. Distribute the 1/3 here and distribute the 1/3 here. And we are done. All righty. So n is now going to become 1/2 A sub 1 plus 1/2 B sub 1 plus 1/3 C sub 1 minus, positive times a negative is negative, 1/3 times 1/2 is 1/6 A sub 1. Positive times a negative is negative. 1/3 times 1/2 is 1/6 B sub 1, comma, 1/2 A sub 2 plus 1/2 B sub 2 plus, and now the distribution, 1/3 C sub 2. Positive times a negative is negative. 1/3 times 1/2 is 1/6 A sub 2. Positive times a negative is negative. 1/3 times 1/2 is 1/6 B sub 2. Whew. Okay. Now we need to cancel stuff out. I have a minus 1/6 A sub 2. Okay, no, let me undo that. Let me just look at this for a second. Okay, so I'm going to try to show you what are like terms with color. So here's an A sub 1. Here is an A sub 1. And I don't see any other A sub 1s. So n is now going to become 1/2 A sub 1 minus 1/6 A sub 1. So this would be 3/6 minus 1/6, which would be 5/6 A sub 1. Okay. Made a mistake here. 1/2 minus 1/6. 1/2 is 3/6. multiplying top and bottom by 3. 3/6 minus 1/6 equals 2/6. I said 5. And then I just rolled 5 because I said 5. Ay caramba. 2/6, which equals 1/3. So this is going to be 1/3 a sub 1 plus, and now let's look at the b sub 1 and the b sub 1. So now we already had 1/2 minus 1/6. We know it's a third. So that is going to be 1/3 b sub 1 plus 1/3 c sub 1. There's no other c sub 1s. Comma 1/2 a sub 2 minus 1/6 a sub 2, and again 1/3 or 1/2 minus 1/6 is 1/3. So that is going to give us 1/3 a sub 2 plus 1/2 b sub 2 minus 1/6 b sub 2 is 1/3 b sub 2 plus 1/3 c sub 2, 1/3 c sub 2. So there is the formula. That's where n will be. If I do it 2 more times for the midpoint of AC and the midpoint of BC and going a third and going a third over, it would end up at this same point n, where it's 1/3 a sub 1 plus 1/3 b sub 1 plus 1/3 c sub 1 comma 1/3 a sub 2 plus 1/3 b sub 2 plus 1/3 c sub 2. There is the formula for the point of concurrency of the medians. Okay, so I guess this formula right here is called Tyler's formula. So part B now says, let A be this point, B be this point, and C be this point, be the vertices of a triangle. Where will the medians of the triangle intersect? Okay, so in other words, you find the midpoint of each, midpoints of each side, and then go 1/3 the distance to the opposite vertex, and we want to find them. So we're just going to use this formula right here. Okay. So the first thing we're going to do is label our diagram, our not our diagram, but our points. So let this be a sub 1, b sub 1, a sub 2, b sub 2, c sub 1, c sub 2. So now we're going to have the point 1/3 a sub 1 plus 1/3 okay, I labeled these wrong. Let A be the point a sub 1, a sub 2. I labeled these wrong. A sub 1, a sub 2, B sub 1, B sub 2, C sub 1, C sub 2. All right, so 1/3 a sub 1 plus 1/3 b sub 1, which is 13, plus 1/3 c sub 1, which is 23, comma 1/3 a sub 2 plus 1/3 b sub 2 plus 1/3 c sub 2. Okay, so I'm going to use a calculator for this. All right, so we're going to do 1/3 times negative 23. I'm just going to do it all at once because we're going to get weird decimals. Plus 1/3 13 plus 1/3 23 again, this time positive. And that gives me 4 1/3. comma, and then we're going to do the same for the b's. So it's going to be 1/3, 12, which we know is 4, plus 1/3, 36, which we know is 12. We're just going to use the calculator, plus 1/3, whoops, -1, which is -1/3. And that will give us the point 15 2/3. So what that means is if we put this triangle on a Cartesian coordinate plane and graphed it out, then the point 4 1/3, comma 15 2/3 would be the point of concurrency of the medians. All right, page 3 brings us to exercise 2, and it says to prove that the diagonals of a parallelogram bisect each other. All right, so I brought in this diagram here, but I want to point something out to you. Let me just put a coordinate plane on here. It's in the first quadrant, so that's all I need. So just to help you out with this, this is X and this is Y. Okay, like so. So this is the point 0, 0. And if I go to the right a distance of A, this is the point A, comma 0. But to get from here over to here, that is a distance of B, where B is more than A, or I'm sorry, B is more than 0, but less than A. So that means if I came down here, this is the point B, comma 0, if you will. Does that make sense? So this is over B, up a distance of H. This is the height H. So if this distance here equals this distance here, and the distance from here to here is A, because A minus 0 is A, this has a length of A. So this has a length of A. So this distance is B and this distance is A. So the X value is B plus A to get to here. And that's where this XY comes from. Okay. So hopefully you understand that from that explanation. And let me just get this out of the way here and get rid of our coordinates. All right. No longer need that to explain how we got those 4 points. All right, so anyhow, it says prove that the diagonals of a parallelogram bisect each other. In other words, this point here is going to be the midpoint of QS and the midpoint of PR. So the midpoint of PR is going to equal 1/2 y2 minus y1. I'm sorry, x2 plus x1. So let's just do it that way. Let's just write the formula first. x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. We'll use this formula because it's easier in this situation. So the midpoint of PR is going to equal, and so PR is here. P is our first letter. So this is x1, y1, and this is x2, y2. The midpoint of that PR is here. All right. So it's x1, 0, plus x2, b plus a. And I'll put that in parentheses so you know that that's my x2. All divided by 2, comma, y sub 1, which is 0, plus y sub 2, which is h, all divided by 2. Okay, so that simplifies to the midpoint of PR equals b plus a over 2, right? The 0 cancels, and the 0 cancels here, comma, h over 2. So there's a midpoint of PR with respect to the way we name these vertices. All right, so now we're going to do it again for Q and S. So let's call Q X sub 1, Y sub 1, and S X sub 2, Y sub 2. Okay, so the midpoint of QS is going to equal X sub 1, B, plus X sub 2, A, over 2, comma, Y sub 1, H, plus Y sub 2, 0, over 2. Okay? So then we simplify this, and the midpoint of QS is going to equal nothing I can do with B plus A over 2, and H plus 0 is simply H over 2. So B plus A over 2, comma, H over 2, B plus A over 2, comma, H over 2 are equal, and therefore we have just proven that M is the midpoint of both, and therefore since midpoints are halfway points, then PR bisects QS. Okay, page 4 brings us to the end of lesson 13. Go to your problem set.